Hey everybody, and welcome to the Frosty Drew Observatory and Science Center live stream. Tonight we are streaming live views of the occultation of the Mars from the moon. On the screen right now, you can see Mars in the skies. The camera we're using tonight is a grayscale camera, so our views are going to be largely in black and white. Unless other team members join in on our live stream, then we might be able to get some color data. Though this camera we're using will offer different views. We'll be able to see wide field views. We'll be able to see views of the moon and Mars, and then close-ups of Mars as well, and some of the landforms that are existent there. As the night goes on, we'll offer periodic commentary, but for the most part, it's just going to be views of the occultation. And in a couple minutes, we'll go into detail about what's actually happening tonight. But for now, enjoy some of the views of Mars. Okay, so in your view right now, we've just zoomed out the camera a bit, and you can see Mars sitting up just in this view on the camera, just above the moon. But our telescope tonight is got the view upside down. So in reality, you're going to see Mars below the moon. And I might adjust the camera here real quick to see if we can get this a little bit more realistic from the point of view here. That's one of the good things about the camera. So we can just twist it right around like this. And that's just about matching right there what I'm seeing in the sky. Everything attached here, and we're going to get our focus back in a little bit. There we go. And even looking at the moon tonight is the full moon. And when we have the full moon, it's often the worst time to be looking at the moon because the moon is in direct sunlight. And as a result, we don't get to see many of those really great landforms that we would often notice on the moon, like Copernicus crater, Kepler crater, and some of the detail you see in these craters because shadows are not getting cast. And without having shadows cast, the craters appear a bit flat, which is definitely not the truth when it comes to the lunar terrain. I'm just doing a couple quick adjustments here on our focus. Try to get the best we can. Now you'll notice that the view does appear slightly wavy as well. This is kind of zoomed in right here on Kepler crater. This right here is Copernicus crater. Bring the gain down a little bit to get a view of it. Copernicus crater is roughly about 60 miles in diameter. And these craters are some of the younger craters on the moon. We call them ray craters. Now going back to our full view here, bring Mars back in, and we'll talk a little bit about what we're seeing tonight. There's Mars down there, looking all nice and hot. All right. So a lunar occultation, when we think about where objects are in the solar system versus how we see the night sky, there's a possibility where objects that are closer to us can end up overtaking or moving in between objects that are further away. Now, looking at the night sky, or the daytime sky for that matter, there is a path across the sky that's called the ecliptic. And the ecliptic is the path that the sun takes across the sky, and it represents the plane of the solar system. So along the ecliptic, you're going to find all the primary planets, and you're going to find a lot of other objects as well, including the moon. Now, Earth's moon is quite large for Earth. So instead of Earth orbiting around Earth's equator, kind of like Jupiter's moons do, Earth's moon orbits 5.1 degrees inclined to the ecliptic. So what that means is any object that's roughly 5 degrees above or below the ecliptic in Earth's sky becomes a candidate or a target for occultations with the moon, where the moon can overtake that object. Now, Mars, like all the other primary planets, orbits quite close to the ecliptic. And tonight, the lunar position is going to place the moon right along the path or the visible path of Mars, or into the line of sight. Now, though we see the moon cross the sky from east to west every night, the same we do the stars, that's due to Earth spinning on its axis. The moon's motion itself is actually eastward. It goes from the west to the east in the sky. And that's because the moon orbits the Earth in a prograde manner, which is counterclockwise. And about every day, the moon will orbit about 13 degrees eastward in the sky. Now, what we're seeing tonight with this occultation is we're actually going to be able to observe some of the motion of the moon as it's moving against the direction of the sky and then overtaking Mars. Now, it's important to note tonight is also the full moon, and this is the January full moon. It goes by the moniker the full wolf moon of January. And we're out here tonight at Frosty Drew, and at Frosty Drew, we're in largely the wildlife refuge. And though we don't have wolves in Rhode Island, we do have a lot of species that are similar, like coyotes and fox. And during this time of year, we often hear the coyotes in the wildlife refuge while we're out here. They're observing the night sky or doing our data collection. And it's possible that we may hear some tonight, which would go very nicely with the full wolf moon. Additionally, in 2 more days, Mars is going to reach opposition. Now, opposition happens when Earth ends up in between a planet that's further away from Earth and the sun. And it's an alignment. And that largely places the outer planet into best viewing for us. Most of the time, it means that we're the closest on that day, but with Mars's very elliptical orbit, usually the closest point is a day or so before or after opposition. So there's a lot of things happening this week. We have the full wolf moon tonight. We have the opposition of Mars coming on the 15th, and we have the occultation, or the lunar occultation of Mars occurring tonight. So we're going to zoom in a little bit here on Mars, get a little bit better view of the red planet here. And as the occultation approaches, we're going to keep zooming in on Mars, really get that view of Mars dropping behind the moon. Now, it is a little windy out here tonight, so we have a little bit of motion in the telescope. This is largely a product of the wind. And you also will notice that the view appears to be a little bit, almost sometimes like you're looking in a reflection in the water. What you're experiencing with that is called convection. We have convective currents rising in the air. I mean, we had the sun out for a very little bit of time today. The ground's kind of warm. And as all this heat radiates off the ground and rises up into the atmosphere, it changes what we call the refractive index of the atmosphere, which is the point at which colors come to focus. And that refractive index shifting will make it difficult to keep the object in the perfect focus, which is why it looks like it jitters a little bit. Now, looking at Mars, you'll notice that even though we are looking at Mars in grayscale, you can see some of the darker regions against the brighter regions. These darker regions are what we would call Maria. And these are some of these regions are canyons on Mars. Some of them are areas of much more rigorous terrain. But you also notice right at the top left of Mars, there's a bright spot right on the edge. And what you're looking at there is one of Mars's polar ice caps. Now, as we observe Mars this year, Mars is every other year due to its roughly 685-day orbital period. We're observing Mars right around, I think it's right around the springtime on Mars right now. So we're kind of getting Mars where it's not tilted towards or away from the sun. And that's allowing us a pretty decent view of both of the polar ice caps. Now, tonight's occultation is going to kick in right around 9:24 Eastern Standard Time for our location here at Frosty Drew, which is on the southern Rhode Island coast in southern New England. And New England, especially southern New England, is one of the most fantastic spots to observe this occultation because it's going to happen right around the middle of the moon. Now, once the occultation occurs or starts happening, it's going to be a matter of maybe 60 seconds before Mars actually drops behind the moon. Once this completes, we have almost an hour and 10 minutes before Mars will re-emerge from the other side of the moon. And at that point, the occultation is completed. So we're going to step off so you don't have to listen to me talk. And we're going to shift the view a little bit. We're going to keep Mars in a view. And once we start seeing the moon enter the field of view, I'll jump back on and offer a little more commentary. Enjoy the view, please. So what you're seeing right now is a live view from Frosty Drew Astronomy team member Derek Schott's telescope that he has his phone attached to. And you can see that the moon and Mars are very close to each other. At this point, looking up at the moon in the sky, Mars is so close that to the unaided eye, you can't even really see Mars. It's buried in the brightness of the moon at the moment. Now, in Derek's image there, you can definitely see how close Mars is getting to the edge of the moon. Okay, so we are now at the point where Mars is beginning the occultation. We're actually seeing Mars at the moment drop behind the moon. Look at this out of your way. And Mars is now being completely overtaken by the moon. And you'll notice how fast that occultation occurs. And what you're observing, this is actually the motion of the moon in the sky. And it's during these occultation periods where we actually experience that type of activity occurring, where you can actually see the motion of the moon, and not just the moon moving across the sky as we see it over the course of the night, but actually the moon moving against the direction of the sky in its eastward prograde motion. Now that Mars has been occultated by the moon and is now out of view, we're going to take some time to kind of jump around to other objects, because we have a good hour and maybe 10 minutes, hour and 7 minutes before we see Mars again come back out. And in that time period, that's a lot of just lunar observation to be had. But just to give a quick tour of the moon here while we have it in view, I mean, the moon it is full tonight. So again, we are looking at the moon without any depth perception or any detail. But some parts to note. So the angle we have the moon at tonight is a little bit off axis because we're using a telescope that is not equatorially aligned. And this is giving us a point of view of the moon as you would see if you actually look straight up in the sky at it. Now, the region we're looking at right here, this is called Mare Imbrium. And Mare Imbrium, this really large, dark area. The lunar mare is the Latin word for sea. And when the ancient astronomers looked at the moon and they saw these dark regions, you know, the dark regions that give us the face in the moon, or the bunny in the moon, or the frog in the moon, or the bicycle in the moon. I see the bunny. These ancient astronomers thought these were bodies of water. I mean, we have them on Earth, they're the dark regions. It makes sense the moon has them too. But as our optics got better and our understanding of lunar geology got better, we realized that instead of looking at bodies of water, what we're actually looking at are basalt regions or lava basins. But to be even more precise, these are the very first impact craters that had occurred on the lunar surface. And they occurred during a period in the moon's history when the mantle of the moon was still completely molten and only the lunar crust had cooled. This was very early in planetary formation. This orbit had a lot of objects in it called planetesimals, which are all part of the building blocks in planetary formation. And some of these planetesimals started to impact that new lunar surface. And those impacts were significant. And they had cracked open the crust, allowing the magma, that lava from the mantle, to pull back into those craters. And in that process, that lava brought back heavier elements like iron that were settling towards the lunar core. And they dried on the surface. And those heavier elements reflect less sunlight than the surrounding crust material. So thanks to those planetesimals, we have the bunny in the moon, or the frog in the moon, or the face in the moon, whatever you tend to see. Now, looking around the region here, I'm going to center right now on this crater. This crater we're looking at here, which it looks very round, but it doesn't look very deep. This is called the Plato crater. And the Plato crater is actually a very old crater. At first glance, it looks like it might be young, but it's actually quite old. Adjust our exposure here just a little bit. There we go. Now moving around, over in this region here, we have, this is the Archimedes crater. And you have this line of mountains that surrounds Mare Imbrium. Over here on the right, these are the Montes Apennines. Just above these are the Montes Alps. And then to the left by Plato crater is the Mons Caucasus. Dropping down below Plato crater, we have this very large half crater feature. And this is called Sinus Iridum, which is also known as the Bay of Rainbows. And maybe about 7 or 8 years ago, you may remember the China had their lunar lander touch down on the moon. It was called Jade Rabbit, and it had driven around a little bit. And once lunar night set in, and it froze to death, and we didn't see anything else from it. But that was in Sinus Iridum. So moving around further, we can start to see the Copernicus crater right here. Now, the Copernicus crater is what we call a ray crater. You can see that there is a significant amount of ejected matter visible all around Copernicus crater, as well as there's a lot of the walls are quite detailed. You don't see them tonight because we're in the full moon, so there's not a lot of relief in our view. But you'll notice that you have a inner and outer crater rim. You have a little peak system in the center. These are all indicative of a young crater. And Copernicus crater, being a ray crater, is quite young. And when we look at craters like Copernicus crater, we can get an idea of what newer craters look like. Now, when we say young, we're not talking like 6 weeks or 6 months or even 6 years. This crater is about 160 million years old. And I guess a big burning question here is, if the moon is 1/4 the size of Earth, 1/16 the mass of Earth, then where's all these craters on Earth? Because when you look around the moon, there are just craters everywhere. It's what we call saturation. There's no part of the moon that's not a crater. New craters happen in old craters. And the answer to this is actually pretty simple. Earth has active geology, and we have a liquid mantle. We're largely just tectonic plates floating around on this liquid mantle. We have a very, very active atmosphere. These processes are constantly resurfacing Earth. I mean, you can test this. You can go to the beach. You can stick your foot in the sand at the wave line and watch the next 2 or 3 wave cycles erase your footprint. Earth's constantly resurfacing. The moon, on the other hand, doesn't have active geology anymore. It doesn't have an atmosphere. It has what we call a surface boundary exosphere, which is a very thin atmosphere that doesn't really do much. So the only thing that resurfaces the moon or the lunar landscape are impacts. And now that we're no longer in planetary formation in the solar system, we're out of the protoplanets, there's no more planetesimals floating around our orbit. The moon doesn't get hit by very large objects regularly. Instead, the moon gets hit by about 100 tons of small meteorite impacts per day. And these small meteorite impacts, instead of leaving impact craters, they actually chisel away at some of the features that are already on the moon. And they slowly erase the landscape. They flatten out the craters. Older craters that have been subjected to this type of crater, of small impacts for much longer, have been flattened out. They appear very rounded off. Some of them don't even look fully like craters anymore, where younger craters are much more visible. Then you can see that very detailed crater rim. You can see the little mountains in the center of the crater. It's a bounce back that occurs when that impact happens. Kind of like when you throw a pebble into a lake or into a pond and it bounces back from the center. You can see the ejected matter around the crater. And though the Copernicus crater has fabulous ejecta around it, this discussion is bringing me to the next object I want to show you, which is the fantastic Tycho crater. Tycho crater is one of the most dramatic ray craters on the lunar surface. Tycho crater's ejecta covers 2/3 of the lunar surface. In fact, when you take a look at the Tycho crater, you can see that the crater is very, very visible. You can see the lines of ejecta shooting out in all directions. But one of the things that really stands out when you look at Tycho crater is that dark ring that surrounds the crater itself. It almost looks like it's in a small lunar mare. And what happened here is that this impact was so intense that the crust had cracked open And this impact reached into the mantle. And even though the mantle was not molten, there was so much energy in this impact that it liquefied a small part of the mantle and then deposited it around the crater itself. And just like the ray craters when they formed, when that molten mantle had cooled, it reflects less sunlight than the surrounding crust material. That's how intense this impact was. Now, the Tycho crater is about 50 miles in diameter. If you were standing in Tycho crater, you wouldn't say, hey, look at me, I'm in a crater. You would feel like you were in a valley with mountains in the distance in every direction you looked, and that's the crater walls you're looking at. Tycho crater is on the south side of the lunar surface. Now, when we think about the moon as well, we always see the same side. We've heard of the Pink Floyd album, The Dark Side of the Moon, and there is no dark side of the moon. Every side of the moon gets the same amount of sunlight and darkness as the other regions do. But as far as Earth's view goes, there is an other side, and that is the side that we don't ever see. And that's because the moon is tidally locked to Earth. What that means is that it takes just as long for Earth to complete one full rotation on its axis as it does to complete one full orbit around Earth. So the moon's sidereal period, which is how long it takes to orbit Earth, is 27.3 days. And that's also how long it takes for the moon to complete one full spin on its axis. So one day on the moon is 27.3 days. Now, as far as phases go, the phase cycle of the moon from, say, the full moon all the way to the new moon and back to the full moon, that's 29.5 days. And we call this the synodic cycle. And the reason why the synodic cycle is slightly longer than the sidereal period on the moon is because in that 27.3 days that the moon orbits Earth, Earth has moved a little bit along our path around the sun. And phases on the moon are a product of direct sunlight and what part of the moon is being illuminated by the sun. So in those 27.3 days, Earth and the moon have moved enough around the sun to extend the phase cycle just a little bit. So continuing to move around the moon, moving up now towards the upper right side of the moon, we have some ray craters, we have some lunar maria, that really round lunar mare right at the top, that's called Maria Crisium, the Sea of Crises. When you look just directly below it, you look like you have three lunar mare from left to right, slightly moving upwards to the right. The roundish one on the left with the ejecta splatter line moving right through it, that is Mare Serenitatis, which is also known as the Sea of Serenity. To the right of that, which is right in the center of our view, is Mare Tranquillitatis, which is the Sea of Tranquility. And the Sea of Tranquility is where the Apollo 11 mission had touched down. And the Apollo 11 mission touched down, and don't get all excited, you're not going to see it. We can't see it with any earthbound telescope. But the region it touched down is right over in here. But speaking of which, looking at Mare Serenitatis, right over in here, right where Mare Serenitatis and Mare Imbrium come together, on the very edge of the Montes Apennines here, is where we have the Apollo 15 landing site. And when you're not, the full moon, you're not going to see anything. But when you have like a 75% or an 80% waxing gibbous moon, you have enough relief from shadows cast from the Montes Apennines that you can actually see some of the features that are visible in the Apollo 15 landing site images. Features like Rima Hadley, which is like almost like a crevasse or like a crack in the lunar landscape. There's also Mons Hadley, Hadley Mountain, and then there's also Hadley Crater. And they're all in this region, right at the top of the Montes Apennines. So I'm going to zoom back out here for a little bit. I'm going to stop talking. I'm going to get the moon relatively centered here in our view. Pretty much on Copernicus and Tycho crater. These are some of the sexiest craters in view. And I'm going to leave it here for a minute, and then we're going to take a look at some other objects in a couple minutes, and I'll get back on and start yammering again. So enjoy the view. Okay, so we're a little bit more than a half an hour out from the re-emergence of Mars from behind the moon. The occultation is ongoing at the moment. And we're going to take the telescope now, and we're going to try to move around a little bit and take a look at some of the other objects in the sky. The next object we're going to shoot for is going to be Jupiter. So if we can get a view of Jupiter and maybe some of Jupiter's Galilean moons. Now you might be able to hear the telescope right now. This is tonight where you're using our 11-inch Celestron Schmidt Cassegrain telescope. All right, so now we have Jupiter in the telescope. Atmospheric conditions at our location have gotten a little bit choppier, as you can see with the waviness that we're seeing with Jupiter here. Now I'm going to try to zoom out a bit so we can catch a view of Jupiter's Galilean moons here. Jupiter's Galilean moons are quite dim in reality compared to Jupiter itself. So to catch a good view, usually you have to push up the exposure pretty high to actually get a view of those moons. And in doing so, we lose view of any of the detail that we'll see on Jupiter's cloud tops. There we go. That's a pretty good view. And you'll notice here you can see all 4 of Jupiter's Galilean moons. Now, I'm not too sure at the moment which moons we're looking at. I'm going to assume that the moon closest to Jupiter at this moment is probably Io. And of the 3 on the right, the brightest one we're seeing is likely going to be Ganymede, which is the bottommost one. And that topmost one is likely going to be Europa. Now, when you think about Jupiter, Jupiter's Galilean moons do orbit Jupiter around Jupiter's equator, unlike Earth's moon, which orbits closer to the ecliptic, which is a path that the sun takes across our sky, which is a plane of the solar system. It's also why we get this great occultation tonight. Now, when you think about Jupiter, unlike Earth with a 23.4 degree axial tilt, Jupiter only has a 3.1 degree axial tilt. And as a result, the moons always either pass in front or behind Jupiter on every rotation. Now, when we look at the moons tonight, you'll notice that on one side, you see 3 moons that are kind of forming what looks like a little bit of an arc there. And what's happening here is that when the moons are orbiting either behind Jupiter or coming out from behind Jupiter, they're going to appear lower in our view. And this is because of Jupiter's small 3-degree axial tilt. Moons that are kind of moving in front of Jupiter or coming out from the front of Jupiter are going to appear a little bit higher in the view. So the moons themselves are not actually in a position where they'll appear to be over top of each other. It's just from our point of view due to Jupiter's axial tilt. Now, if we zoom out, or not zoom out, but bring our exposure down so we can actually see Jupiter's equatorial bands, you'll notice that the equatorial bands on Jupiter are going to be largely in the same orientation as where the moons are, because the equatorial bands sit over Jupiter's equator. Now, these equatorial bands, these are a product of Jupiter's differential rotation. Now, when you think about Jupiter's composition, Jupiter's a gas giant. Its primary element is hydrogen, but the areas of Jupiter we see are largely the cloud tops. And Jupiter's upper cloud tops have three different levels. You have the most upper level is ammonia, the center layer is water vapor, and then the lower layer of those clouds is also ammonia. Now, as Jupiter spins on its axis, the polar regions on Jupiter spin much slower than the equatorial regions on Jupiter. And this creates a drag on the upper cloud deck. As the equatorial region spins quickly, the clouds start to move along that area very fast, and they clear out just above and below the equator. And that gives us these stripes that we see called the equatorial bands. And along these equatorial bands is where we're actually observing lower into Jupiter's atmosphere. The southern equatorial band is where we always see the great red spot, which is just an anticyclonic storm that has been ongoing. And that storm will draw in a lot of clouds behind it. It's almost like a wake that stays in that storm's path when the storm passes through. Now, I'm not seeing the red spot tonight. Usually you can see there's a distortion, but not having a color camera as well makes it a little bit more difficult to observe the red spot, though I'm not seeing it tonight. Now, Jupiter was at opposition in, I believe it was in early December, and you can see here there's some of those moons again. We'll bring the gain down. We'll put the exposure up instead. Give us a better view of them. There we go. Now, on nights like tonight, though, we don't, with the moon being so bright, we obviously are not going to be able to see any nebulae or star clusters, and that's because the moon's just too bright for that. And it brightens up the night sky or the atmosphere, Earth's atmosphere, to where the atmosphere is illuminated more so than the actual light of the nebulae and galaxies that we'd be trying to observe. Now, if we zoom back out to full resolution, you'll notice that Jupiter is much smaller in the view. We're going to send the telescope back to Mars right now, which would be right on the moon at this point. And there it is, the moon. Crazy bright. We're going to bring our exposure back down here. We're going to bring our gain back down. And you can notice too that based on where Mars is now, we're pretty much on the opposite side of the moon from where we're looking. All right, we are about to experience the re-emergence of Mars right now from behind the moon. So we're looking somewhere in this region here is where we're just about to see Mars come back out into view from behind the moon. Oh, there it is. That's it coming through right there. Now, you'll notice how quickly Mars re-emerges from behind the moon. I mean, it's just a matter of seconds that it takes the moon to move enough just for Mars to come back into view. Now that Mars is re-emerged, the occultation is completed. Though Mars is still too close in the sky to the moon to see it naked eye yet, over the next 15 to 20 minutes, Mars will start becoming more visible to the naked eye, just right next to the moon. Now we're going to switch over real quick here to the blue filter. And with the blue filter, we'll probably be able to get maybe a better view of the ice caps. You can kind of see it right there, little region right on Mars there. These are our narrowband filters, so you're not going to see much with the narrowbands. And then this here is just full broadband. This is no filter. So we're going to keep the view on Mars for a little bit as outset continues. And then we'll wrap up the live stream in the next few minutes. Give Mars a chance to kind of sneak out a little bit there. Okay, so we are coming into the end of the occultation right now. Mars has re-emerged about 15 minutes ago, and it is now visible to the unaided eye in the sky next to the moon. If you have a window or are willing to step outside in the not too cold temps tonight, take a look up at the moon. And just to the top right, you'll see the little red star-like object there, and that's Mars. Now, we appreciate you guys tuning in to our live stream tonight. We'll be archiving the live stream on our YouTube, and we'll put chapter and links in the description for notable parts of the actual occultation, like when Mars becomes occulted, when Mars reemerges. Now, Frosty Drew, we open up every clear Friday night year-round, and now that we are in the winter season, this is more of our down and off season, so this is a good time to visit. You don't need tickets typically. You also get more time with the astronomers and with the telescope because less people come out. So check us out online at frostydrew.org/events, and hopefully we'll see you out one night at the observatory.